Hi guys, welcome to the notes for 12-5. This one's titled, How Can I Use Matrices to Solve Systems? This is a continuation of our lesson from yesterday. Yesterday you learned what a determinant was and how you can use it to find the inverse of a matrix. We're going to use the inverse of a matrix to help us solve an equation that contains all matrices. So let's get started. First of all, just a quick review. It says here, how are the two matrices inverses of each other? Sorry, I can't read sometimes. So are the two matrices inverses of each other? You see we have matrix A and matrix B. Now there's a couple options, a couple things we could do. If you remember how to find the inverse of a matrix, you could check to see if, let's see here, let's just write down these options. We could see if A inverse equals B, or we could do, we could see if B inverse equals A. Either way, right, if we find the inverse of one of these and it equals the other one, then they are inverses. But there's a third way here that I think is probably going to be easier for you to use, right? So we could also take this and let's say if we multiply matrix A times matrix B, if they are truly inverses of each other, remember that's going to equal the identity matrix, right? Remember the identity matrix for a 2 by 2 is 1, 0, 0, 1. That main diagonal has all ones. So when you multiply, it's just like when you multiply, 1/2 times 2, right? We end up here with 1. 1 is like our identity for multiplication. For our matrices, it's like our identity matrix here. Okay, so when we do something that are like inverses, like 1 divided by 2 and then 2 divided by 1, those are like reciprocals in that case, but that would be an inverse operation, multiplying by 2 versus multiplying by 1/2. So let's check this out here and see if this works with our matrix A and matrix B. Let's just go ahead here. We know that this is a 2 by 2 and this is a 2 by 2. All right, so since they share that common value in the middle, right, the number of columns in A matches the number of rows in B, that means that our resultant matrix would be in a 2 by 2 also. Let's set up a little template for our resultant matrix. Remember, we're going to have 2 by 2 in here. And when we start multiplying, we've got row 1 times column 1. So we should have 3 times 1 is 3. And then 4 times -1/2 would be -2. And then we'll go over here and we'll do row 1 times column 2. And we've got 3 times -2 is -6. And then 4 times 1 is 4. Now let's take these and let's go down to row 2 and column 1. 1 times 1 is 1 plus 2 times -1/2 would be -1. And then we'll do our last set here where we've got row 2 times column 2. And when we do 1 times -2, that's -2 plus. Then we have 2 times 1 is 2. And now let's just find the simplified version of each of those. 3 plus -2 is 1. 1 plus -1 is 0. -6 plus 4 is -2. And -2 plus 2 is 0. And as you can tell, since this is not the identity matrix, right, it doesn't match what we have right over here. Therefore, these are not inverses. So A and B are not inverses. Okay. If we would have gotten the identity matrix out of it, then we would have said, yes, they are inverses. Let's move on. This problem should look familiar. It says, how can we use inverses to solve an equation like this? This problem we started talking about in yesterday's lesson. We started talking about how we would want to isolate this unknown matrix in the middle, the one that contains the x. And in order to do that, we had to multiply the left side by the inverse of this matrix. So we didn't actually do it yesterday, but we're going to do it now. So remember, we want to multiply by the inverse of, we'll call that like, like matrix A there, right? Okay, so what we would need to do then here is this. We would need to take it and find the inverse of matrix A to begin, right? So if we have 3, 1, negative 2, and 1, and we're trying to find the inverse. Remember, the inverse is denoted with that little negative 1 up in the exponent like that. So remember, it's going to be 1 over the determinant, and then we were going to multiply it by, that special 2 by 2 matrix that will come from these elements. And we'll talk about that in a second if you forgot what it was. So remember, the determinant of A is going to equal our A times D, so 3 times 1 minus 1 times negative 2, which is going to be 3 plus 2, or 5. It looks like 25. I forgot my equal sign. So we're going to put that determinant right here, right? So it goes in the denominator. Then we're going to take it and we are going to flip-flop these two numbers. So this becomes 1, this becomes 3. And then we're going to take the opposite of this and the opposite of that. So this would be a positive 2 and this would be a negative 1. So if you're thinking about like mathematically, how does that work? Well, we would take that and we would say, all right, we're going to multiply the left side times that expression. Okay, so this is what you would see here if we were writing out every single step along the way, right? And this would be our x. And then if I did all this times the left side, then I'd also have to do all of that times the right side. And order matters. So if it comes first here, it's got to come first over here. So we're going to do 1/5. And then we've got our 2 by 2 matrix. That's 1, 2, negative 1, and 3. Right? And then we're going to multiply that by the 2 by 2 matrix that's already over there, the 8, 2, 1, and 9. Okay, so what does this all do right here? So when I multiply all of this together, right, my resultant matrix would end up being the identity matrix, right? So when we multiply something times its inverse, it should give us the identity matrix. So that would be something like this, 1, 0, 0, 1. And remember, in terms of matrices, that's like 1, right? When you multiply something times the identity, it remains itself. Okay, so really, instead of actually even writing out this next step here, right, if I was to multiply these together, this is actually just going to end up being still just that unknown matrix. Okay, then what we're going to do here is I would take this and multiply this part of it together first before distributing that 1/5 through the first matrix. Let's go ahead and do that. So I'm going to bring down that 1/5, and then my 2 by 2 matrix that I would have after multiplying those, right? So hopefully we're getting better at this, but it would be 1 times 8 is 8, plus 2 times 1 is 2. If you have no idea where these numbers are coming from, then you need to go back and watch the second lesson, 12-2, to remember how to multiply these. All right, so then we're going to go into row 1 and column 2. We've got 2 plus 18. And then we're down into row 2, column 1. So negative 8 plus 3. And then we're in row 2, column 2. We'd have negative 2 plus 27. So when we simplify those, we're going to end up with 10, 20, negative 5, and 25. And now we can multiply that 1/5 times each of those elements, and we're going to find our unknown matrix. Our unknown matrix is going to end up being 2, 4, negative 1, and 5. Okay, so just to kind of sum it up here, right, that means if I was to do this original problem, we had 3, negative 2, 1, and 1, and I multiply it by this 2 by 2 matrix that we just found right here, right, we'd have 2, 4, negative 1, and 5, and it should end up equaling that 2 by 2 matrix where we've got 8, 2, 1, and 9. And just to show you that here, right, I'm going to pull out my calculator, and you can see here, I already have them plugged in. as A and B, but you see there that I get that same matrix, 8, 2, 1, and 9, even if I do it on the calculator. Okay, and we'll review how to do it on the calculator here shortly. So remember, the answer, though, is this part of it right here. Let's move on. So from our homework last night, hopefully you figured out how to solve this system of equations. It says that the solution here was 2, -4. Okay, now we can actually solve these systems of equations, 2 by 2, 3 by 3, whatever by whatever, using matrices. So down below it says show that this system can be written as this statement right here. Well, let's show that, right? This is a 2 by 2. This is a 2 by 1. So if I'm multiplying those together, remember they contain, those inner dimensions are the same, which would give us a resultant matrix that's 2 by 1, which you see right here, this is 2 by 1. So if I take this here, and let's actually do the multiplication now though. Okay, so I know this is going to end up being a 2 by 1 matrix. So I'm going to start out by doing this row times the column. So we'd have 4 times x plus 2 times y. And then we'll switch to the bottom row. We do 1 times x is x. Oops, I need to switch my pen. Plus 1 times y is y. And right now this should still equal 0 over -2. Right? And since this is now a 2 by 1 and this is a 2 by 1, notice they have the same dimensions. So if they're really equal to each other, remember then that means all of the elements must be equal. So that means 4x plus 2y should equal 0, and x plus y should equal -2. And just like that, you'll see that's the same as the system that we have up here. All right, this can cut down on your work quite a bit when you're solving large systems of equations. Let's move into this next part here. And so now we're actually going to show how we can solve that system using our inverse matrices. Okay, so this is putting together both parts from these past 2 lessons. So as I look at this here, right, I'm going to name these. I'll just call this A, B, and C again here. So if I do matrix A times matrix B, it should equal matrix C. So A times B is equal to C. Now I'm going to try to cut down on the amount of writing that you have to do. Like 2 slides ago, we did a whole lot of writing here to solve this problem. And when you do it by hand, you kind of have to do that. But I'm going to help you by showing you how to do it on the calculator with this one. So first of all, this is what we need to imagine, right? Our unknown matrix here is matrix B. So if we're solving this equation, we need to get matrix B by itself. So we said that we're going to have to multiply both sides of our equation by A inverse, right? Because what I now have then would be A inverse times A times B is going to equal A inverse times C. And we know that this is the same thing as the identity matrix. So when we're multiplying the identity matrix times B, we're still going to end up with just B. And then our B should equal A inverse times C. So this matrix right here should equal the A inverse. And remember, we can write A inverse just like this, 4, 2, 1, 1. And then we'll raise it to that negative first power. That's important there, right? That shows us that it's the inverse of that matrix. And then we're going to be multiplying that times our matrix C, just like that. Okay, so now we could find the determinant and rewrite it and do everything there, but I'm going to show you how to do it on the calculator with this one. So we can actually take this and put this all in and get our answer. Let's see how it works. So I'm going to bring out my calculator here. I'm going to go into my matrix menu. So if you're using one of the other models of calculators, you should know how to use it by now. We've done enough of these. So I'm going to go in here. This is still going to be a 2 by 2, but I'm going to change my elements to 4, 2, 1, and 1. Okay, and then I'm going to go quit out. I'm going to come back in. and I'm going to edit my other matrix here. Remember, this one's just a 2 by 1, so we're going to go 2 by 1. So make sure you change that dimension, and then we'll put in there the element on top is 0, and the element on bottom is -2. Okay, so now we've got those entered in. So A and B, actually this was C, but for what I typed into the calculator, it'll say B. So let's do this. So second matrix, I'm going to go ahead and just choose my first one. Now, if I want to denote it's the inverse, right? If I want to denote that what I'm typing into the calculator is the inverse, remember this button that is 3 below second, the one that we keep doing second and then clicking on it there to get into the matrix menu, this button right here, hopefully you saw that there, gives us the inverse. It'll raise it to that negative first power like that. And then we're just going to do times, and then we're going to go in and put our second matrix in. So that would be this one. Okay, but if you forget about putting the inverse on there, it's not going to do, very good things for you. It's going to take you away from your answer instead of towards it. So let's hit enter, and you see it actually spits out the answer that x is going to be 2 and y is going to be -4. And thinking back, right, isn't that what our answer was originally? 2, -4. Now I know with linear systems of equations, you're probably going to just do it using the methods that you already know. But sometimes we'll get some bigger ones, some like 3 by 3s and things like that here, that it'll be much faster probably to do it by matrices. And we'll do one of those before we're done. So let's go into this next one. This one's just going to ask us to solve this system of equations by first writing it as a matrix equation and then solving it by hand. So this one, we can't just use that calculator shortcut. We'll solve it by hand. One thing you need to definitely check here are, our terms in the same order. In this case, they are. They're both in standard form. So we're going to take this and we're going to create a matrix at the beginning here by doing this, right? We're going to take our elements, and this one would be our numerals, 2, 3, 10, and 16. And then we are going to multiply those by a 2 by 1 matrix that's going to contain x and y. So whatever the first one is would be on the top, and then the second one would be on the bottom. And this should equal, so we're multiplying those together, this should equal our answer, which is 1 and 2. All right, so if we're going to do this one by hand, let's just start out here, right? We know that we need to get this by itself, so we're going to say this unknown matrix should equal the inverse of our matrix from out in front, so that'd be 2, 3, 10, and 16. And we'll raise that to that negative first power. Again, don't forget that part. And then we're multiplying that times this last matrix, which I keep trying to write as a fraction, and I don't know why. All right, so to find the inverse of this matrix, right, let's just do it up here, right? We're going to need to know the determinant. The determinant is going to come from doing 2 times 16 minus 3 times 10, which is going to give us 32 minus 30, which is 2. So remember, that would be 1 over the determinant times, and then we've got our 2 by 2, where we're now going to flip-flop these two. So 16 is up here, 2 is down here, and then we're going to take the opposite of this and the opposite of that. So that would be a -3, and this would be a -10. And we're still multiplying it by this 2 by 1 matrix, that's 1 over 2. All right, so if it's me, I'm going to go ahead and multiply the two matrices together first, and then deal with the 1/2 afterward. So it's a 2 by 2 times a 2 by 1, so our answer should be a 2 by 1. And we'll go ahead here and just do this row and this column. So 16 times 1 is 16. -3 times 2 is -6. So 16 plus negative 6. And then we'll move down to the bottom row and using that same column, we'll say negative 10 times 1 is negative 10, and then 2 times 2 is 4, which then should give us, what, 16 plus negative 6 is 10 over 6. And then when we multiply that, I don't know why I keep putting fraction bars in there. I get all excited. Sorry. There you go. We don't all hate fractions. I like fractions. But we're going to do our scalar multiply. We're going to multiply it through. 1/2 times 10 is going to be 5. 1/2 times 6 is going to be 3. So that means that our x value should be 5 and our y value should be 3. If you're writing as an ordered pair, it would be saying like 5, 3. Okay, so we solved that one by hand. How could you check it? Well, let's just take it and plug those points in. Why go through all that work there if you're not going to check to see if it's right or wrong? So we're going to do 2 times 5 plus 3 times 3 equals 1. So that's 10. And uh-oh, what happened there? Oh, notice I caught a boo-boo, right? This should be a negative 6 here. So this should be a negative 3. So good thing I was checking my work, huh? So now I'm going to do 10 plus a negative 9, and it does equal 1. And then let's go over here and do the second equation. 10 times 5 plus 16 times negative 3 should equal 2. 50 plus a negative 48 or minus 48 should equal 2, and it does. So we've checked them both. But it was a good thing I did check it there, right? Because I had one of them wrong. Okay? It's a lot of work to do if you're going to get it wrong. So let's move on here and let's look at, a much bigger, longer one. But don't worry, we're going to use the calculator to help us with this one. And you'll see how much easier it becomes. So the first thing it says to do is to write this system as a matrix equation. Then use a calculator to solve for A, B, and C. So the first step here is we have to make sure they're all in the same form or the same order. Okay, so you'll see this one goes, A, B, C, constant. This one down here is A, B, C, constant. But the one in the middle is not, so we need to rewrite that first. So it looks like we'd have 2A's. I'd have to subtract across a 4B, so 2A minus 4B. I'd have to add a C, and then move my 7 to the other side. Okay, and then I'll just recopy the rest of them down. A plus 2B minus 3C equals 2. And then we have A plus 4B plus 2C is equal to 8. And just, special note, let's say there was a variable missing. If a variable is missing, you'll insert a 0. I can't write anymore. I'm running out of neatness. So if a variable is missing, replace with a 0. All right, so let's turn this into matrices now. So remember the first one we do, right? You're going to think about all of your coefficients. Right, so we're going to take our 1, 2, negative 3, 2, negative 4. This is like 1. And then we've got 1, a 4, and a 2. So we'll make this 3 by 3 matrix over here. When I say 1, 2, negative 3, 2, negative 4, positive 1, and then 1, 4, and 2. And we're going to multiply this by our matrix will have A, B, and C in it there. So we'll say A, B, and C in that same order. And then this should equal this part. So we're going to have a 2, a 7, and an 8 down there. All right, so once you have your original matrix set up, the only thing you need to do, you don't have to show me the determinant and that you're multiplying by the inverse on both sides. Right, let's just set our unknown matrix here equal to the inverse of that first matrix. All right, So remember, the inverse is denoted with that little -1 up there. And we're going to be multiplying it by, we have 2, 7, and 8. And now we can go in and just use the calculator to get it. So I bring this out, I'm going to go into my matrix menu. Let's edit here. I'm going to use that first one. I'm just going to type right over it. So this is a 3 by 3. And in here we'll have 1, 2, -3, 2, -4, 1, and then 1, 4, and 2. Okay, so that one's in there. And then let's quit out. Let's go back in. And then let's just go ahead here and edit our matrix B. This one is a 3 by 1. And we'll have a 2. We'll have a 7, and we'll have an 8. All right, now back to our home screen. We're going to do second matrix. We're going to bring up our 3 by 3. So that's like our matrix A. We want the inverse, so please make sure you raise it to that negative first power. Press that inverse button. And then we're going to say times, and we're going to put in that second matrix. So second matrix, and this would be B. And when we hit enter, you'll see that our values of A, B, and C pop up. So we've got 4, 1/2, and 1. So that's what A, B, and C are. So A is 4, B is 1/2, and C equals 1. And you can feel free there to take those and plug those in to check. But for the time's sake with the notes here, I'm going to tell you that that is correct. So one more time, just recapping the steps though, right? Step 1 here is to write it with our matrices in the equation. Step 2, let's take it here and we're going to isolate the unknown by multiplying by the inverse of that original matrix. Remember, order matters here. This is really important. Order matters. So don't forget that, right? This is going to come before that last matrix. And then the third step is just simplifying it there. Awesome. So we're almost finished. So if you want to take a moment there, you could set this one up and try to do it and then just check to see if you get it correct. It says, Billy's Restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $1.50 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations and 20 fewer roses than daisies. So the total order came up to $589.50. It says on worksheet 4, we came up with the following system to represent the given information. So we see that here down below. And you may or may not have had the exact same equation, but it's okay. So we want to take this now and try to solve it using matrices. So first thing, again, remember, we need to get them so that they're all 3 in the same order. Okay, so I like the first one, C, then R, then D equals 200. I'm going to rewrite that here. C, we had plus R plus D equals 200. Our second one, we're going to have to move our D over. And then we have no C's. So remember, when there's no term, we're going to put a 0C. And then I'm going to have plus R minus D is equal to -20. And then the last one looks like it's pretty good, right? So we have 1.5C plus 5.75R plus 2.6D equals 589.5. Okay, so that's really important here is just this first part to make sure that this one's written in the same order as everything else. Now we can build our matrix. So let's set up that 3 by 3. We're going to have a 1, a 1, and a 1, right? That comes from our first row. Our second row 0, 1, and negative 1. And then our third row, 1.5, 5.75, and 2.6. So when we multiply that, we're going to multiply it by a 3 by 1 matrix, which should be our variables, right, in that same order, C, then R, then D. And that should equal 200, negative 20, and 589.5. So to get our answer, again, we are trying to isolate this one. So we're going to have to multiply by the inverse of that one. So it should look like this. We'll have our C, R, and D equals, just go ahead and write them in. Kind of bled those ones together, sorry. Don't forget to take your inverse. I know I've marked it every time. Hopefully that means you're going to check for it every time. And we're going to multiply that times our 200, negative 20, and 589.5. So if I was to try to make you do this by hand, you'd probably hate me forever. So again, let's pull out our calculator and do it right on there, whichever model you like to use. I'm going to go into my matrix menu. I'm going to go into that first one under edit, 3 by 3, so enter, enter. Okay, so here we go. I've got 1, 1, and 1. And then we have 0, 1, and negative 1. And then we have 1.5, 5.75, and the last one there, 2.6. Just wanted to make sure I didn't make any boo-boos on there. So we're going through it. So that is all in there. And we also need to go in and enter our last matrix. So we'll go back into our matrix menu. Let's go to edit again, and let's go to B. And it looks like we would have a 200, negative 20, and 589.5. All right, finally able to solve it. So let's go to our matrix menu. Now don't go into the edit. Let's just choose our A. We want A inverse, so let's just go ahead and press that inverse button. And then we're going to do times, and we're going to have our matrix B that we just created right here. And then we hit enter. You see we get 80, 50, and 70. So let's see if I can fit that in here. That'd be 80, 50, and 70. So if C is the number of carnations, there would have been 80 carnations. Our R is going to be the number of roses. And our last letter D was the daisies. And we said there'd be 70 of those. I think I spelled daisies wrong. There we go. All right, so there were 80 carnations, 50 roses, and 70 daisies sold. If you take them and plug them in there, it should work. That's all I got for you. I know it was a little longer. Hopefully it makes sense. If you have questions, you can reach out or you can rewind and rewatch and do what you need to do. Have a great day.